Hello everyone, my name is Deeksha and today I will be explaining my home automation project based on IoT which was done under Emertxe. IoT or Internet of Things is a network of physical objects embedded with software, sensors and actuators that connect and exchange data with other devices and systems over the internet. IoT devices can range from smart home appliances to even industrial machinery. These devices collect and share information to perform tasks and provide insights without direct human intervention. Things in IoT. The things actually refer to the actual devices which are connected to the internet, and they are usually embedded systems that are enabled to communicate and interact with their internal states as well as the external environment. IoT is advancing automation rapidly today and it is enabled by infrastructure provided by cloud services. The reasons why IoT is booming is due to widespread internet connectivity, lower cost of hardware, and cloud computing. Let us look at what embedded systems are. Embedded systems are a combination of hardware and software, and they are designed to perform a particular task, often as a part of a larger system. Embedded system has several components. The first one is a microcontroller, which is an integrated circuit that is capable of being programmed to perform a specific task. The second component is memory, and there are three different types of memory: ROM, read-only memory, RAM, random access memory, and hybrid memory like EEPROM and flash. The third component is sensors, and these are devices that detect physical quantities from the environment and convert the quantities into electrical signals. Examples of sensors are LDR sensor, pressure sensor, etc. Actuators. These devices convert electric signals into physical actions. Examples are relays, LEDs, motors, and they are usually used for outputs. User interfaces. User interfaces are some devices that can help the user to interact with the embedded system. Examples are displays, keypads, etc. Programming a microcontroller. Programming a microcontroller and in general embedded systems is done using C and C++ language. C is a general purpose procedural programming language that was initially designed for system programming. It is a mid-level language and has elements of both high level and low level. High level as in sense it contains constructs like functions and data types, whereas it can also have elements of low level because it can access the memory easily using pointers. C is known for its efficiency and performance, and it is known for its memory management as well, which makes it ideal for embedded systems development. C++ is a superset of C language and supports procedural, object-oriented, and generic programming. It provides core OOP concepts like classes, objects, abstraction, inheritance, polymorphism, and encapsulation. This helps in making modular and reusable code. C++ comes with a rich standard library that provides various functionalities including input, output operations, data structures, and algorithms. So the project is home automation based on IoT, and the flow that was used for the project is as follows: the purpose, the requirement, design and the components used, the development, and finally the implementation. The purpose of the project was basically to develop an IoT based home automation solution. The solution had three main requirements, which was the first one was controlling the brightness of garden lights, the second was controlling the temperature, and the third one was controlling the inflow and outflow of water in a serial water tank. The Blynk IoT mobile application was used to assist in remote control of these devices. Let's look at the requirements in detail. First one was garden light control, where the garden light's intensity is controlled based on the availability of sunlight. The second one is temperature control system, where the temperature of the system is displayed on an LCD display as well as on the Blynk app. The temperature is also controlled by the heater and cooler buttons on the Blynk app. The heater will be automatically switched off whenever the temperature exceeds a threshold of 35 degrees. The third requirement was water tank control, where the volume of the water in the tank is displayed on the LCD display as well as on the Blynk app. The volume of water is controlled by the inlet and outlet valve buttons on the Blynk app, and whenever the volume of water falls below 200 liters, the inlet valve is opened automatically. The hardware requirements for this project were simulated, and there were two major simulators used, PixSimLab and Null Modem Emulator. PixSimLab is a real-time emulator of development boards, and it provides integration with MPLAB-X and Arduino IDE for programming the boards. It supports microcontrollers like PIC controllers, Atmel AVR controllers for Arduino boards, ESP32, STM32, and many more. It provides connection of spare parts or other sensors and actuators used in any implementation, and this can help in simulating. The second one was Null Modem Emulator, which is an open source virtual serial port driver for Windows, and it creates paired COM ports to simulate serial communication between the host application and the simulator, which is PixSimLab. In this project, PixSimLab was used to simulate the Arduino Uno board, which was used. The software requirements are Arduino IDE and the Blynk IoT app. Arduino IDE is an open source code editor and a development platform for embedded Arduino C and C++ programs. The Blynk IoT app is a mobile app, and it also consists of a web platform which can help in building, controlling, and monitoring IoT devices remotely through customizable widgets. It offers a dashboard where the displays and the control of the devices can be observed. The project made use of a few components. The main ones are one of the main ones is the Arduino Uno. Arduino Uno is based on the ET-Mega 328 microcontroller and is used as the main controller for this project. It has 14 digital input-output pins, out of which 6 are offering pulse width modulation. Apart from these, it has 6 analog input pins, which have a resolution of 10 bits in the analog to digital converter. And these pins are used for sensor and device interfacing. The specifications of the Arduino Uno are displayed here. A few other components used are as follows. Arduino communicates with other devices using serial communication. Serial communication is required for communicating and exchanging data with the serial water tank, which is simulated by PixSimLab. The I2C communication protocol is used for interfacing with the LCD display. The Ethernet shield W5500 is added for connecting to the internet through a serial peripheral interface bus. This is essential for connecting the Arduino to the internet, through which it can communicate with the Blynk cloud and accordingly with the Blynk app on a mobile phone. A 16 cross 2 character LCD, also known as CLCD, is interfaced with the Arduino Uno board to display information to the user. It can display status information like the temperature, the water level, the water volume, as well as the heater, cooler, and the valves of the water tank. This allows monitoring the system's operation in real time. Blynk app. The Blynk cloud enables us to remotely control and monitor the hardware devices like Arduino through the internet using a mobile app or a web dashboard. The Blynk app acts like a bridge between hardware and user interface and enables seamless cloud connectivity. It has three main components: the Blynk app, the Blynk cloud, and the Blynk library. The Blynk app is a user interface to control and monitor the devices. The Blynk cloud is a server that connects the device and the app over the internet. It securely handles data exchange between them. The Blynk library is a software library that runs on the microcontroller in Arduino and communicates with the Blynk cloud. Blynk IoT has introduced a feature known as virtual pins, which are software-based communication links that allow data exchange between the mobile Blynk app and the Arduino program. These virtual pins transfer sensor data, they control device states, and also send feedback between the app and the device. During the development of the project, two major functions used to facilitate this data exchange are the Blynk write and the Blynk virtual write. Blynk write is a function that's used when the device receives data. For example, when a button on the app is pressed, this information must be communicated to the device, which is the Arduino microcontroller. Blynk virtual write is a function used when the device sends data. For example, sensor readings obtained by the Arduino is sent to the app and displayed on the dashboard. The next step was the development. There were a few steps followed. First one was installing libraries and including header files. The main libraries used were the liquid crystal I2C, which was essential for displaying information on the CLCD, and the Blynk library, which was needed for interfacing with the Blynk cloud. Header files used were wire.h, liquid crystal I2C.h, SPI.h, Ethernet.h, and Blynk simple Ethernet.h. These were used for different functionalities in the project. For example, connecting with the internet, connecting with the CLCD display, etc. The second step was defining the pins. All the pins used in the project, input and output on the Arduino Uno, as well as the virtual pins for the Blynk app, were defined. The third step was internet and Blynk setup, where the credentials needed for connecting to the Blynk cloud were defined, including the authentication token. The fourth step was initializing the devices. Initializing the devices included the CLCD display, as well as beginning a connection to the Blynk cloud and setting the timer for Blynk messages. The fifth step was control from the app, where widgets on the Blynk app were designed and they were assigned the virtual pins and data streams that were created for the project from the Blynk cloud. The sixth step was sensor data feedback, where the sensor readings are displayed on the CLCD as well as the Blynk app, and the actuators are controlled through the app via the buttons and widgets which we had designed on the Blynk app. Examples of these actuators are the LED, heater, cooler, and the tank input and output valves. Let's look at the implementation of the project. The garden lights LED control was achieved by using an LDR sensor. LDR is a light dependent resistor which works based on the photoconductive effect, and its resistance decreases as light intensity decreases. So when there is a lot of darkness, the voltage readings decrease, and as a result we program the Arduino Uno to increase the brightness of the LED. This is done by the PWM feature, which is the pulse width modulation feature provided by pin 3 of Arduino Uno. It can be used to control the brightness of the LED based on the duty cycle of the output. As the LDR sensor analog readings decrease, the duty cycle of the output pin 3 is increased. So we can observe here that when there is sufficient light intensity, the LED is switched off. When there is low intensity, that means there's darkness, the LED glows and it's quite bright. The second functional requirement was temperature control. The temperature control system makes use of an LM35 temperature sensor, a heating resistor, as well as a cooler. The temperature readings from the LM35 sensor are displayed on the CLCD as well as the Blynk app. The temperature is controlled by turning on or off the heater and cooler buttons through the Blynk IoT mobile app. Three major virtual pins used for this functional requirement are V0, V1 and V2, which were used for cooler control, displaying the temperature on a gauge, as well as heater control respectively. So we can observe in this diagram that at the device location we have the Arduino Uno and it's connected to the temperature system as well as the CLCD, and on the left we see the Blynk IoT app, which is located remotely, and we can directly control whatever the temperature is at the device location remotely with the help of the Blynk IoT app, which is connected to the Blynk cloud. The third requirement was serial water tank control. In PixSim Lab, the serial remote tank is a tank simulator controlled by a serial communication protocol. In this home automation application, the following sensors and actuators are read and controlled by this communication protocol. The actuators used are inlet valve and outlet valve, and the sensors used are water volume. The water volume is displayed on the CLCD and the Blynk app. The tank valves are controlled by turning on and off the inlet and outlet valve buttons through the Blynk IoT mobile app. Three virtual pins were used here as well, and they were V3 for displaying the water volume, V4 for inlet valve control, V5 for outlet valve control. Let us now look at a small demonstration of the project. The code was developed using the Arduino IDE. Since there are no errors and has already been compiled, I will now load this hex file into the PixSim Lab simulator for Arduino. This is the PixSim Lab, which simulates the Arduino Uno board. Along with this, it has a few sensors and modules that are connected. We can see the LCD display here, the LED, the LDR sensor, the temperature system, the Ethernet shield. I will now load the hex file for this project. As you can see, the temperature is displayed as 27.34 degrees Celsius. Also, the volume of the serial tank is increasing. So let's look at the serial tank, which is connected here. The inlet valve is open because the water level was below 2000 liters. We can take a look at the mobile app, which is Blynk. As you can see, the inlet valve is open here. I'm going to switch it off now. and the message that is displayed on CLCD display is as inflow off. If I switch on the outlet valve, the water level will start decreasing, and accordingly the display message on the CLCD is outflow on. I will switch off the outlet valve now. This comprises the water level tank control. Let us now look at the temperature system. Once I switch on the heater, the temperature will start rising. This is all being controlled by the Blynk app on the mobile phone, and accordingly you can see the temperature rising and the display message is heater on. As soon as it reaches 35 degrees Celsius, the heater pin just turned off, which was a requirement of the home automation system. I will now switch on the cooler, and accordingly the display message on CLCD is cooler switched on. I'm switching off the cooler button now. The next requirement was the garden lights control system, which could detect the darkness or light intensity and decrease and increase the LED brightness accordingly. So when I regulate the darkness or light intensity by changing the resistance value over here, the glow of the LED decreases and increases accordingly. So this concludes the demonstration of the project. Thank you.